This is my second video covering rationalizing rational expressions. So if you haven't already looked at the first video on this that was called dividing and rationalizing, make sure you do so or else this video is not going to make a whole lot of sense. So I finished the last video by asking, well, what happens if we want to rationalize something that has more than one term? Specifically for us, it's going to be two terms. So how do we rationalize a denominator with two terms? And we're going to see that it's similar to what we were doing when there's one term, but it is going to be a fair bit more complicated. Not in terms of the idea, but just in terms of actually pulling it off. There's going to be a lot more multiplying and simplifying involved. So let's say we wanted to rationalize, for example, 1 over 1 plus root 2. So it's about as simple of a two-term thing as I can make. This, by the way, does also kind of extend to thinking about 3 terms or 4 terms or 5 terms. We're not going to do anything past 2 terms in this course. It is doable. It just requires more work. It's kind of taking what we're using in this video and applying it in slightly different ways and kind of doing it multiple times. So for us, we're going to cap out at 2 terms. So let's think about this. Remember last time when we were doing just a single term, all we had to do was multiply by the root. We would multiply, say, this one by root 2 on the top and the bottom. But if we do that on the bottom here, we're still going to end up with a root. Feel free to try it for yourself. See what happens if you multiply the top and the bottom of this by root 2. It's not going to work. Your next thought, if you were kind of trying to figure this out on your own, might be to do it with 1 plus root 2. But you'll find out that that doesn't work as well. You're just going to end up with a bunch of terms on the bottom. So to do this instead, we're going to multiply the top and the bottom by something a little different. So you're going to get a new vocab term here. So the top and bottom by something called the conjugate of our denominator. And so I'll explain what that means in just a sec. All right, so conjugate. The conjugate is pretty similar to whatever your denominator is, with just a little bit of a change. So the conjugate has the same terms, so it's still going to be a 1 and a root 2, with a slight difference. What we do is we're going to take the sign of the second term, and we're going to swap it from positive to negative, or negative to positive. Full disclosure, it doesn't actually have to be just the second term. You could do the first term instead. But I find it easier to just stick with doing the same thing every time. So for me, I'm always just going to switch the sign of the second term, even if doing it the other way might be slightly easier. So what I'm talking about when I say all this, the conjugate of, let's just make it generic and say a plus b is going to be a minus b. So same variable, same terms, just the second one is now negative instead of positive. So before we start rationalizing things, take a second. I'm just going to give you a few examples to think through real quick. And we're going to try to find some conjugates of a few different things here. So let's say we had 3 plus 2 root 5, root 2 minus 1, and negative 2 root 6 plus, I don't know, let's say 3 root 7. So try to find the conjugates of all 3 of those. Pause, take 30 seconds, and then come back and see if you understand. So the conjugate of the first one is just going to be 3 minus 2 root 5. The conjugate of the second is going to be root 2 plus 1. And the conjugate of the third is going to be negative 2 root 6 minus 3 root 7. So all I've done is I've just taken that second term and I've just swapped it from negative to positive or positive to negative. All right, so let's see how this works for rationalizing. Back to that original question of rationalize 1 over 1 plus root 2. So our conjugate, which I wouldn't normally write out, but I'm going to do it just for this one. Our conjugate is 1 minus root 2. So we're going to do 1 over 1 plus root 2, and then we're going to have to multiply by 1 minus root 2 on the top and the bottom. And when you do this, please, please, please be careful and make sure you FOIL. It's by far the most common place people are going to mess up here is just not foiling things. So be really, really careful with this. On the top, if we multiply 1 by both of those things, because this is about as easy as this one can be, we're just going to end up with 1 minus root 2. On the bottom, if we FOIL carefully, 1 times 1 gets me 1. 1 times negative root 2 is going to be negative root 2. Root 2 times 1 is going to be plus root 2. And then root 2 times root 2 is going to get me 2, but specifically minus 2 because it was a positive times a negative. If we simplify this, the top is just 1 minus root 2. On the bottom, you'll notice that the negative root 2 and the positive root 2 are going to cancel out. And that is the advantage of using a conjugate. That's going to happen every time, which I'll show you in a sec. So what we're left with those gone is just 1 minus 2. Well, 1 minus 2 is negative 1. And in this case, we can simplify this and actually get rid of the denominator. That's not always going to happen. But if we divide everything by negative 1 here, we're going to get just negative 1 plus root 2. And so we've even gotten rid of our fraction. Again, not going to happen every time. So let's think a little bit more generically. What happens in general when you multiply by a conjugate? Why does this help us? So if we're thinking of this in terms of, let's not even think roots, let's just think variables. So if we have a plus b times a minus b, if I FOIL those, we've got a times a, which is a squared, a times negative b, which is negative ab, b times a, which is positive ab, and b times negative b, which is negative b squared. So notice that no matter what they were, those two terms in the middle have to cancel out because of the a plus b times a minus b, the way this works. And then the a squared and the b squared, well, even if those had roots, those are now just going to be, well, not roots because we were squaring them, so the roots are going to cancel out. Keeping in mind, this really only works for us when we're dealing with square roots, not cube roots. So in this course, we're just going to max out at 2 terms, and we're just going to be dealing with square roots because otherwise this gets way, way, way more complicated. So don't sweat it otherwise. So let's try this in action. We're going to rationalize 6 over 7 minus root 3. And so we're going to multiply the top and the bottom by our conjugate, which is 7 plus root 3. On the top, we can distribute. So 6 times 7 gets me 42, and 6 times root 3 gets me 6 root 3. On the bottom, if I FOIL, I get 49 plus 7 root 3 minus 7 root 3, and then minus root 3 times root 3, which is just going to be 3. People do really tend to mess up on the squaring and the just overall values here, so do be really careful. Those two terms on the bottom, again, are going to cancel out. Really, once you get into the swing of this, you don't even have to write those. You can just recognize that they are going to cancel. And so we're left with 42 plus 6 root 3 over 46. And so in the last video, I talked about what you can and cannot simplify. So in this case, because all 3 of our things outside of the brackets here are 42, our 6, and our 46, or sorry, outside of the root, because all of those are divisible by 2, I can divide everything by 2 here. I don't care about the 3, it's inside of a radical, so that one doesn't matter. So if I divide everything by 2, I'm going to end up with 21 plus 3 root 3 over 23. And that's as simplified as this one is going to get. It's fully rationalized, and it's fully reduced. If you end up with a root in your denominator at the end, you know you've messed up, because the whole point of this was to get rid of any roots in your denominator. So it is something to think about. If you see a root down there, just please try to keep in mind, oh, hey, that's wrong. That shouldn't be there. All right, so try this next one for yourself. See how it goes. It's going to be just a little bit more complex, not a lot. And we will talk afterwards. All right, So our conjugate here is going to be 4 root 2 plus 3 root 12. So we're going to do that on the top and the bottom. So if we distribute up top, that's going to get me 32. And then root 2 times root 2 is just going to get me 2. Then it's going to get me 24. And root 2 times root 12 gets me also 24. On the bottom, 4 times 4 gets me 16. Root 2 times root 2 gets me 2. So really don't mess that up. I'll see a lot of people who will say, oh, okay, 4 times 4 is 4. But those aren't in a root, so they do get multiplied fully. Then our two middle terms, we're going to have 12 root 24. So we're going to add that and subtract it. And then the 3 root 12 times 3 root 12 is going to get me minus 9 times 12. So we simplify everything that we can right now. So 32 and 2 gets to be 64. 24 and 24. Well, hey, 24, that's something I can pull something out of. So I'm going to be able to pull out a 2 from that, which is going to leave behind a root 6. Then on the bottom, 16 times 2 is 32. Those middle terms have canceled out. And 9 times 12 is 108. So we've got 64 plus 48 root 6 over negative 76. And so you look at those, you see if you can simplify everything. You can. They're all divisible by 4. Which is going to get you 16 plus 12 root 6 over 19, or negative 19. There's one more thing we can do here. We also typically don't like to have negatives in denominators. So what we're going to do is we're going to multiply everything by negative 1 just to get a positive denominator. It just makes things look nicer. So we're going to get negative 16 minus 12 root 6 over positive 19. And there we go. This one is rationalized. You might have noticed, if you were paying really close attention, way back at the beginning, we actually could have simplified all 3 of our roots. So we could have divided all of those by 2 right from the get-go, which would have made this question much easier. We would have had much smaller things to deal with. So you can simplify from the beginning if you notice that it's possible. All right, one last one for you to do on your own. The only difference on this one is you're going to have 2 terms on the top and the bottom, so it's just going to mean more stuff to keep track of. So be really careful working through this. Be careful with your foiling, be careful with your prime factorizations, pull things out properly, and see how you do. All right, so our conjugate is going to be negative 2 root 2 minus 5 root 6 on the top and the bottom. Keeping in mind what I said in the first bit of rationalizing, or first bit of this video rather, we could actually have done positive 2 root 2 plus 5 root 6, so you can change either of the terms, and it would have been totally fine, and it probably would have made this one a little bit easier. So if we go through and we FOIL, on the top and the bottom, we're going to get negative 8 root 6 minus 20 root 18 minus 2 root 10 and minus 5 root 30. On the bottom, negative 2 root 2 times negative 2 root 2 is just going to be 4 times 2. And I'm going to skip the middle terms because I know they're going to cancel out. The 5 root 6 and the 5 root 6 is going to get me negative 25 times 6. On the top, the only thing I'm going to be able to simplify is just the 18. So this is going to become negative 8 root 6 minus now 60 root 2, because I pulled out a 3, minus 2 root 10, minus 5 root 30. And then on the bottom, we'll have 8 minus 150, which, you know what, I'm just going to do that right now. And I'm going to say that's negative 142. That's a whole lot of negatives, so let's multiply the top and the bottom by negative 1 to make this just look a little bit nicer. So we're going to get 8 root 6 plus 60 root 2 plus 2 root 10 plus 5 root 30 over 142. There will be times where you're going to be able to combine some terms together by adding or subtracting here, so do keep an eye open for that. But that is rationalizing. So it's a lot of multiplication, it's a lot of simplifying, it's a lot of things to keep track of. So now that you got this under wraps, the next thing we're going to be doing is starting to look at solving equations. So once you're ready, go ahead and check that out.